So welcome to a new week with Math B. And thank you if you did some homework over the weekend. More people than ever have done homework. So the again, if your spring term is crazy and you don't have time because of jobs and kids and everything to do much other than just be with us in class, that's perfectly fine. ABSC is happy to have you do only that. You're welcome to be here. I appreciate people being here. But you're probably gonna be in Math B again next term if you're not doing any homework. Okay? That's just how math is. Nothing we can do about that. It's when you do it that you're actually learning it and ready to move on. So much better to be here and not do homework. And then next term, if you do B again, it will be easier and more fun and go smooth. But just don't fool yourself, right? If you have a lot of stuff going on in life, that's okay, people do this. That's one reason this doesn't cost anything for you. So, but, yeah. So anyway, thank you again if you were of the people who did homework. On our Moodle page, I've now gotten down through multiplication and division with editing things up and putting the videos in that you might want to look at and everything like that. We're not jumping right there yet. We are still doing stuff in addition and subtraction because we are on number 16 towards the end of the subtraction ones. I want to check in, kind of blending those two things. Is our system working for everyone? For the people who are doing homework, are we spending enough time in class on things that look like the textbook and homework, even though we're trying to make it fun and colorful and interesting? Or are we doing too much of things that aren't just me demonstrating textbook problems? Because they can always do more of that if you want.
No, what you're doing is fine. I like it because it warms your brains up, makes the brain working.
That's true, but that doesn't work for everyone. So I hear your vote.
I definitely agree. I would definitely agree with that. It does warm our brains up. I would like to see a little more in the textbook describing that kind of.
Okay.
But I mean, that's just me.
What I normally do is stay at about like we are until I get done with subtraction. And once we get to multiplication, then I start doing more examples. Just because in previous terms, I've seen that a typical Math B student arrives pretty good with place value and rounding and estimating and adding and subtracting. But when we get to multiplying and long division, then everyone goes, whoa.
Yeah.
So that's what I'm anticipating, but if my pace is not correct for you, whoever you are, then holler and I will change my pace.
It's good enough for me. You make it too much fun.
I want it to be fun. If I can make you interested in doing the homework, that's often better than making it a little easier to do the homework, right?
It's a lot easier.
Okay, comment?
Yeah, there's a lot of examples of them that you say, but it's not like a clear to me always how, what you're trying to have us try to learn.
Yeah, and some of that just isn't coming yet. We've talked a lot about place value, and when we start doing more with measurement and decimals, all of that will come back and you'll say, oh, that's why he focused on place value so much. And there's,
Not necessarily it's the fact that like, I don't know what you're trying to explain,
right,
like at all, like what, why you're explaining.
why I'm explaining things, yeah.
Yeah. It's like a map, but there's places, but no like dot to dot
Mhm.
where I'm supposed to this. Well, it really is really hard.
I can try and put more dots between the things on the map.
Your soda, go drink your soda, don't
Okay.
choke to death.
So, let me think. In fact, let me do that a little bit. So when we were talking about addition last time, we talked about perimeter, a nice real life application of adding things up. Because we always want to know, why do we care about this in real life? And we talked about the ways that got tricky, so that was because we're studying for the GED, and GED has lots of word problems. Adding up a bunch of numbers isn't hard, so how can they make a perimeter problem trickier? So another thing we talked about was before that. Well, where was it? Here, there was this weird slide about asking how many more. You do subtraction, 16 minus 7 is the answer of 9. But it's also kind of adding, because we were going bigger, 7 and then 9 more, and we got up to 16. So where all of that is going, I can show you, because that's a good thing of connecting the dots, is, did I not put it on here yet? No, I didn't put it on here yet, one moment. There are some that I have built that I haven't put on this one yet, because they don't always copy and paste smoothly.
What I'm gonna be really afraid is,
Yeah,
of is, times tables.
yeah, so this thing here, so let me copy that over and make it big. Let me do that so nicely. There we go, okay. So our big goal with this arithmetic thing is not only to be able to do the arithmetic, although that's not much of a goal, because we have calculators. And except for the very simplest arithmetic problems, the GED will never ask you to do long division or multiply big numbers or things like that. We're reviewing that because it's useful later on. The reason we're talking carefully about all of this arithmetic is this stuff on the slide right now. That when you get a word problem, it doesn't tell you, are we needing to add? Are we needing to subtract? Are we needing to multiply? Are we needing to divide? So what all of these games and activities are doing, in part, is training your brain about the kind of verbs that are happening in word problems. Are we combining things?
So technically, we're waking up our brains.
Yes, but in a specific way, because this is the part that makes word problems hard. When
Sure.
people hate word problems, it's because they're not sure exactly what to do, right? Once you get them, 4 plus 2 out of the paragraph, then you can make it 6 easy. So,
So we're training our brains for, the terminology of word problems.
it's to think about the kind of the verb that's happening. A lot of times, teachers in elementary, middle, and high school are kind of lazy. And they say things like, if you see a word problem and there's the word total, that means addition. Right, but those kinds of rules with nouns, words like total don't always work.
Yeah,
I could give you a paragraph that has the word total, but it's really a multiplication problem, right? I have 3 candies. I give you 3 candies and you 3 candies and you 3 candies and you 3 candies. How many total candies have I given away? That's 3 times 4. That's a multiplication problem, right? So you can't do this type of thinking with the noun, the thing. You have to think about the action, the verb, what's happening. So that's part of what we're doing. If you're combining things, then we're adding. If we're taking away and removing, that's subtracting. But as we saw in last class, if we're starting somewhere and saying how many more to count beyond that to get to a bigger number, that's also subtracting.
okay.
We'll get to multiplying soon. There's 4 actions that are multiplying. We can make copies, like photocopying. We can shatter things into little pieces. Right? If we have 6 cookies and we give half a cookie to everyone, we can feed 12 people, right? Just twice as many. That's multiplying. We can select a fraction of, if I say what's half of 6, that's multiplying, even though we're getting smaller. And the same thing with the fraction, but we could write it as a percent. What's 50% of 6? That's the same as half of 6. It's still multiplying even though the answer is getting small.
It's language but math.
Yeah, and then the real tricky one is the division. Because making equal sized piles out of something is division. That's like dealing out cards, right? If I have 52 cards and I give an equal number of cards to 4 people, then you're all going to get 13 cards, right? But shattering can also be division, even though the picture is the same as we just did for multiplying. If I word it different, instead of I have 6 things and I break each of them into 2, that's 6 times 2 is 12. If I say I have 6 things and I make them into a size 1/2, how many fragments are there? That's also 12, but now we're dividing to get our answer instead of multiplying. And it's very tricky and subtle. And then there's a fraction picture, but it's what fraction out of. If I have 2 out of 6 things are mine, the other 4 belong to you, then 2 out of 6 is a division problem. And the same thing if we write it as a percent. If I have 2 out of 6, what percent is that? That's also a division problem. So this is one of our giant end goals, and it'll take all the way into Math C before you really get a lot of this, because some of the fractions and percents don't happen until Math C. But the goal is that when you see a word problem, then it's quick and easy to know what type of arithmetic you're doing. Because once you know that, the problem isn't hard. You could have your calculator.
Hi, Jeffrey.
Hey, guys.
Hello.
Sorry I'm late, buddy.
That's okay, you're not that late.
Oh,
Did you remember to fix the time with the babysitter? Cause we're not done until 7:50.
No, actually, I did not. I can't do that, but, I can say it, but it's almost to that time, yeah.
okay. Is that a helpful thing to see where we're heading towards?
Yeah, it is.
Okay.
I think I'll have like a little.
New to me, because I never- What you're doing right now, David, that I can remember, I never learned this in elementary school or high school.
Right, and that's.
I graduated from high school, but some of this stuff is new to me because they never taught me this in high school.
Right, and like, there should be stuff that's new to everyone, and unfortunately, that's because. Teachers, until you get sometimes to high school, but mostly to college. Are teaching math because they're forced to, not because they want to, or that they're
Right.
teachers.
My mom and I both have something and Carmen, we're both not good with math.
So there's this long lineage of people teaching math in elementary and middle and high school, and they don't teach it well. And it's not kind of their fault because they were not taught it well either, but it's also kind of the teacher college's. Fault that they should be preparing these teachers better and so on. So if a lot of this is new, or if you can do the.
I probably learned it in high school, but I just don't remember because I graduated high school in '96.
And there's lots of people that can do a certain thing, like, oh, I know how to do multiplication of 2-digit times 3-digit numbers, I've done that for years. But not understanding the background enough makes it just seem like some random process and not understanding why things work. So we'll get to all of that.
I wonder if it's gonna rain.
Yeah, so my job is to make it so that, if you have kids and they're in elementary school or middle school learning this stuff, then you can explain it to them. It's not just something you had to memorize. And
We do have a kid, but the only problem is she's in high school, she's better with math than I am.
Okay, well, anyone need me to put the link to the Jamboard in chat again? I think everyone is.
Do what you gotta do.
No, Nicole.
Do what you gotta do, buddy.
Okay, one moment, let me put it in the. Chat
That's true,
again. And we can do the warm up for today.
What's the warm up, clean the house?
So there's 8 houses. Notice the middle, there's like a
Get out of
cup
here.
that doesn't count as a house. And every house has a different number of people living in it. Now, I've given you 12 numbers, so you're not going to use all of them. You're only gonna use 8 of them, and 4 are distractions, red herrings to mess you up, right? So how many people live in each of these houses? We know that each house has a different number, so we're not gonna copy and make duplicates of any of these. And each line of 3 houses should add up to 15. We did this a little bit similar with the game that was like tic-tac-toe, remember? So see if you've gotten better at that since we first saw it a few days ago.
36 people live in that, and then 8 houses. Heck, that's too many people, I couldn't handle having 36 people living in my house.
Okay. Where's Jeffrey? If you need help, so help you.
Under my computer screen,
So, yeah, we can drag these around. Maybe 1 person is in this house. Or maybe 7 people are in this house, and move the numbers around and try and make it so. Each line of 3 adds up to 15. The diagonals through the middle doesn't matter,
Play with it.
just the outside edges.
Does
Yeah,
it,
just play with it and talk to each other if it helps. I'm not gonna force people to talk. If I have to do one thing, I will encourage people to turn all their cameras on if you haven't yet, just so we can all start the class at least.
so we're trying to like get to 15 at the bottom house at the very end.
All the edges, so these 3 add up to 15,
Oh,
these 3 add up to 15, these 3 add up to 15.
I'm gonna count the windows and then I can figure out how many live in the house. 1, 2, 3, 4, 5, 6.
Don't trust the windows.
Yeah, we did miss the CV.
No one lives in the park.
wait,
Well, no, who lives there, so it's all prepared.
Hey, leave my friend alone, honey.
Gavin's moving that into that zone.
yeah, I can't, or
Oh, move it, let's throw the house up here. Up on top, up on top.
me,
Yeah,
or,
up there, no, you got 10. You brought this one up there, and this one.
Gavin, you're moving me.
I'm not moving anyone.
There you go, I got my houses.
Okay, now we're all set.
Okay, let's check. I'm gonna move this 12 out of the way so it's not distracting. And we don't need one in the middle. We have,
The tree doesn't count?
no, the tree doesn't count. Do we have 15 anywhere? No, all of these are. Now that's way bigger than 15 on that edge.
On this edge, mine,
Yeah, that right side, 7 plus 12 plus 4, that's way too many.
oh, I thought we were trying to add like 15 on each row.
Alright, we want this to be whoops. Here. We want this to be 15, I'm not drawing straight.
Oh,
So right now it's 17, cause 6 plus 4 is 10 and there's 7 more.
like the knight on a chessboard.
Oh, just
Sorry, I thought
the
the
straight up
tree
and down,
counted.
right, we're not turning the corner like an L like that knight moves.
So we're not trying to like have a knight move,
No, just a straight line of 3.
Okay,
but you said there's nothing in like the woods right there.
We're not counting diagonals, right? That one doesn't matter, we're not counting.
And remember, trees don't count.
Okay, I thought you were saying like we couldn't put anything in the
Yeah, you
trees.
don't put any number in the trees and only worry about the outside edges.
Okay,
Okay, 6 and 7 and 2 does make 15, so maybe we need to rearrange those, but those 3 do work nicely along one edge.
well, we could use the 12, can't we, with the 3?
this one is my.
Okay, can I move this 2 back? Okay, now we have 6, 7 and 2.
I'll see 21.
I'll move my fight out of the way too.
Okay, 7 and 9 is already 16. So if you wanna put the 9 there, maybe we should switch the 7 and the 2. Now 9 and 2 is only 11, and there's a little bit more room.
There, how about that?
How about that? Let's see.
So 9 and 4 and 2 is 15, I believe.
Yep, so at the moment, this looks good. And this one looks good.
So when
9 and 1 and 5, that's 15.
there, how about that one?
And yes, so ta-da.
Um,
I got it too, ta-da!
So we're trying to completely black out that whole area, the outline, right?
It says each house has a different number of people, so we need a number on each house. And each line of 3 houses has 15, so this is 15. This is 15. This is 15,
So
that is 15.
so they overlap.
Yep,
I didn't get.
You finished?
I'm still working on it.
Oh.
You wondering?
okay.
No, if you will finish, I get to get to the second one, then I finished mine.
Okay. As we saw a few minutes ago, we're sort of thinking about words and actions as we're reviewing arithmetic. So let's talk about words for subtracting. Subtracting often is what people call borrowing. So if I go to the store and all I have is a $10 bill, and I buy something that costs $3, then what do? I don't have these $3 in my wallet, all I have is this $10 bill. So we pretend that this 10 is broken apart, and instead of having the 10, we pretend I have 10 ones. And then the store person keeps the 3 that are theirs.
Yeah, you bought something, right?
And I get back $7 of change, right? So we're used to borrowing, that happens all the time when we
Yeah.
make change.
Okay.
But that word, borrowing, is kind of the wrong word. When I, in normal life, talk about borrowing something from you, then you think I'm gonna give it back. And I'm not gonna go back to that store, and they're not gonna demand the $7 back, or I'm not going to get the $3 back. And so borrowing
More like.
is the word we're all taught to use, so I want to talk about it, but it's not quite the right word. Other words might be better, so the ones I think about are breaking or fragmenting or splintering.
Yeah.
Right, we're taking this 10
I
and we're breaking it apart into 10 bills, and people will say that in real life, can you break this 20 for me, right?
Oh, yeah.
Or fragment, if you break something into smaller pieces, fragment is a good word for that, or maybe splinter, although sometimes that sounds like it's kind of rough and messy, whereas
Yeah.
this is very organized. Another word is redeem. Redeem means that I can return something to the original owner, like the redemption value on a soda can, right? We're getting money because we're giving that back to its original owner. So if I think that this 10 was originally built from 10 different ones, then we're sort of putting it back the way it was. That's a bit of a stretch, because not all 10s used to be 10 different ones, but if we're counting, that's kind of what happens. We start with the ones, and when we get 10 of them, we swap it for a 10.
Yeah.
So anyway, so just pay attention again to all those actions, because when we start dealing with word problems, then the actions will help us know, oh, I'm subtracting. Okay, your turn to make change. Copy and move the bills as needed. If we have $35 here, and I wanna take away 26 of them, show me how that works. Move 26 of them over to the other side and have 9 of them left on the left side. And then trickier, if I have 132, which we do at the bottom, and you wanna take away 94, now I can't just move 9 tenths, because I don't have 9 tenths. So I have to do something to this $100 bill. Does my task make sense to you?
Yeah.
Yeah, okay, so show me these two subtractions, one that doesn't need borrowing, one that does.
That's what I mean.
And again, copy the bills, move them, do what you need to make this look right.
Oh, I haven't been done at home. No, we want, something very long, I think that, but we want something to put there.
If anyone needs more help just with making the whiteboard work, I can talk about that, because I don't need to be moving right now.
Why, think that, yeah, I was. Oh, no. Let's do that.
Oh, I lied to you, actually, the 26 needs some borrowing, because we don't have 6 ones to take away.
Yeah, I know, it's Jeffrey Mangan.
Okay, I designed this well, they both.
Yeah.
So I think
Well, I
I
didn't
think 100 can borrow, but then again, you're under a week's ones behind.
Yeah, I agree, I think the 100 could be borrowed by a $10 bill.
Or broken up,
Broken up by
You
a
can take the,
$10
you
bill.
can take the 10 and move it away, say we're getting rid of it, and instead have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we've made a fair trade.
Yeah, I'd say $9, $10 bills, you break from $132.
Everyone okay that this is $132? I didn't miscount.
I don't know, I'll just try to.
Well, cause when you try to break it up, cause you get like, it's like, you're taking away like 90.
Here's the other one.
So you have $132,
number to it.
basically, but a few bucks. Pocket.
I didn't just do it like.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that's the 100, and then 30, and then 2. Okay, I think we've done that.
Needs to be between.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Right.
Is this $9 and that I see?
But you can,
Why he was.
how do you do it? Cause if you look, you
Well, then I
look,
do how many.
now they have 5 you get $1 more.
Must be my
Good.
mom.
I think it's a big one, but I.
Alright,
Long as Jeffrey Edwards.
so if I have $10
And it's-
here.
Gavin, you getting it okay?
You need to take control and.
I can't.
Trouble becomes.
Yeah,
Oh.
and then controlling.
Making sure they're locked.
Yeah, and then I can move these and not do the other stuff. So
Yeah.
here's $10.
Always
Then,
someone duplicated the text.
yeah,
What's Penny doing?
so Betty is taking away a 10 and getting 10 ones. So here we go, here's
Oh, wow.
1, 2, 3, 4,
I know, that's
5,
making
6,
me
7,
dizzy,
8,
the fact that
9.
that thing keeps moving around so much.
Yeah. Okay, now we need to take away, we had 35, so we have one more. Okay, now we have 35, right? 1, 2, 3, 4, 5.
Only when I got
7,
that,
8,
when I got
9, 10.
27.
No, we don't have this 10 anymore, it's going away as
Well,
we
I didn't have these.
10 ones.
Like about your teaching now and stuff.
So now if I want to get rid of 26,
And
10,
yeah, I haven't gotten.
20, whoops. 1, 2, 3, 4, 5.
All witches?
What's left is these 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Litigated, right?
Everyone makes sense now.
So we had 35, we put 26 over on the side.
But.
And what's left is
Link in your little.
Okay.
How about at the bottom, we have 100
Yeah.
and 32. I wanna get rid of 94, so here's 90.
You know, duplicate
and I need 4 ones.
Yeah.
So you put two.
So I need to take one of these tens and turn it into 10 ones, right?
Alright.
So 1, 2, 3, 4, 5, let's just make copies of that.
Like I'm supposed to, yeah.
There you go.
So there's 10 ones.
Spirit connected.
So I want to move away 94,
Right.
It's a couple of those, man.
I believe
There you go.
one.
and
Perfect.
what's left is 10, 20, 10,
Thank you for the
20,
time, though.
30, 1, 2, 3, 4, 5, 6, I'm missing a 10, I miscounted
Oh.
somewhere. Okay.
No, I deleted one.
Oh, you deleted, okay, I'll just copy it.
Yeah, copy it.
So here's the 94, and here's the 30, that goes with the 38 right there.
Oh, to zoom in too
I
big.
zoomed in too big, sometimes it zooms automatically.
Yeah.
Okay, so that was probably more confusing than it needed to be.
Yeah.
Let's do this without money. This slide, by the way, is one that I'm not planning on doing whenever I do this lesson. This is a good one if you want to do more at home, or if people really wanted to see more. Or if what we just did worked very smoothly. But let's review how to do this with just pencil and paper. So if I have 84,
You guys later.
See,
I can't remember my password instead, so.
okay,
Yeah. Bye guys.
then I want to take away 15 from 84. I could do 8 minus 1 is 7. But I can't do 4 minus 5. If I have only 4 things, I can't take away 5. I run out of how many things I have. So what I'm going to do is say that these 8 tens, I'm going to replace with a 7. I'm taking a $10 bill away. And then I can say that this 4 isn't just a 4, it's 14. I add that $10 bill as ones. That makes sense with what we just did with the money?
Mm-hmm.
So this 4 is all gone. The 8 becomes a 7, and that 10 now is 10 singles instead of a $10 bill. Now I can subtract 14 singles, I give 5 of them to Gavin. How many are still left in my hand? 9. And 7 minus 1 is 6. Does it help to think about $10 bills and $1 bills?
Mm-hmm.
Yep. Makes it easier.
Okay, with this one, 405 minus 70. I can do 5 minus 0, that's just 5, I'm not taking away any
And
one.
then I would say 0 minus 7 would be 7.
No, I know.
If I have no money, I can't give you 7.
You have to break the 100 down. You need to break 100.
Yeah, so this is like what we just did over here, where we need to take 100 from the 132 and turn it into a mess of tens.
Yeah.
So if I take one of the hundreds away, how many hundreds are left? If I take 1 away from the 4, there's 3 left.
You have 3 left.
And how many tens do I get?
You get 10.
I get 10.
You get 10.
So now I can do 10 minus 7 is 3, and 3 minus nothing is 3.
Yeah.
Mm-hmm.
Questions on either of those two?
No.
No. How about Zoom people? Any questions?
No.
Okay, one more. Can you move your mouse, Sean, so we can?
Oh, sorry.
see it on screen?
Go ahead.
Okay, 385 minus 197. Now we're gonna have to carry twice in one problem.
Oh, wow.
So I don't have enough singles to give Jody 7.
Mm-hmm.
So I'm gonna take one of my 8 tens and turn it into just a 7.
Yeah.
And from that $10 bill, I can get 10 singles. Instead of 5 singles, now I have 15.
15.
And 15 minus 7 is 8. So far, so good.
should you almost have.
Now, 7 minus 9.
So you almost have enough money to go to the strip club.
I don't think I will do that with Jody though. 7 minus 9, I can't do that, I can't give Sean 9 if I only have 700, so let's break the 100. I had 300s, if I break one of them, how many are left? 2. And now instead of 7 10s, I have 17, the 7 I had before, and the 10 I just got from breaking 100.
Yeah.
So 17 minus 9 is 8, 2 minus 1 is 1.
There we
So
go.
$188.
Yep, or whatever it is, these don't have dollar signs on them.
I mean, $188.
I'm thinking of money, because making change with money is something we do,
Yeah.
right? Trying to count whatever, 385 watermelons.
Yeah, when you go, when you go to the store, you have to give them you gotta give them a certain amount of cash and then they give you the change back, and then sometimes they short you and you have to catch them on their mistakes.
Okay, here's a deep thinking problem. When we did our to-doodle at the end of class last time, remember we used jacks as like a temporary 11? 5 and 6 was 11, so we said, oh, let's use jack to think about how this is 11. And then we took this one and carried it up here. Remember all of that from last time if you were here? We're not using playing cards this time.
Darn it, I wanna
Oh.
play with playing cards.
Why not? There's something very different about borrowing and carrying. Maybe you were told by another teacher that borrowing is just sort of undoing carrying. But I can't teach you borrowing with playing cards the way I can teach you carrying with playing cards.
Well, if you use the A's,
At least it's just one, that's.
it can also be a. The other number, the highest.
Item number. Even if it's a 14, that's not really helping. So ponder this at home some. How come we need different physical things, money or playing cards, to think about carrying and borrowing? They're not really as opposite as you might have been told. Okay, now we're gonna do a game, but before the game, I'm gonna show you this warm-up. This one takes a long time to fidget. This is a great one to play with your friends and family members. It's sort of like the one we just did with the houses. You have shapes, and the shapes are a code. Each
How do you get
shape
them?
stands for a certain number, so maybe all of the orange triangles are 3s. Can I copy that? No, I can't, that's really annoying. Can I copy it? Yes, I can, okay. So maybe all of those are 3s. And maybe blue circle stands for 5. Oops, no. I'm not sure, let's try it. And maybe the club, whoops,
Not the kind of club that Gavin's thinking of, can't go to a strip club.
no, I'm not sure why his mind is on that. Okay.
Everyone of age?
Okay, so maybe all the clubs are 4s. If that worked out, then when I added things up, they would turn into these numbers, 20 and 25 and 26. But we can see right away, it doesn't work, right? This row, 3 plus 4 plus 3 plus 5, that's 15, not 20. So I have to change things. But if I change one of the orange numbers and say maybe that's a 4, then all the orange numbers I have to change. Does that make sense?
Yes,
Because they have to stay consistent. So the code of what orange is has to be the same. So it's a extra tricky thing. Can I figure out what orange is and what blue is and what pink is to make this work? We're not gonna do this now, but if you like these puzzles, that's a good one to do.
How would you go about?
How would you go about it?
Yeah.
Well, then we would check the total on the top now, 4 plus 4 plus 4 plus 5. We're getting closer
Two,
to the 20 that it wants to be.
okay.
So maybe we need to make pink a little bigger, maybe we need to make the blue a little, so you play with it, try and make things work out.
How it would be a cryptic.
But this one is not gonna work out unless we have breakout rooms and take a long.
Thanks a lot.
Yeah.
Okay, instead I wanna play a more fun game. This is our first cooperative game, and all the games we've played before, you've been trying to be like the first one to get to 21. Or the closest to 100, or something like that, and even if you were in teams, it was a very competitive kind of thing. Whereas this is a cooperative game. Its theme is the Alice in Wonderland story.
No, I love that.
And Lewis Carroll invented a bunch of games. So maybe he would have liked this. We're gonna make some random numbers. We're going to do it with the spades between 2 and 9, so. Pull out of the deck of cards the spades between 2 and 9. And somebody is going to get 4 cards from that little deck of just the 2 through 9 of spades. And we'll put them in this pattern on the screen, the highest in the top left. The second highest in the bottom right. Then the second smallest in the bottom left, and finally whatever is the smallest of those 4 numbers, the top right. Then we'll treat it like a subtraction problem and get some number. Now, there's a map over here with the numbers by tens, right? 0 all the way to 80. So if your number is, say, 27, you would move your pawn to what's closest to that. And then you get to pick one of these flowers and paint either one, to the right or to the left. If you remember Alice in Wonderland,
I do, that
then
was
the
my
card
favorite
people
thing.
are trying to paint the flowers red before the queen gets there. Cause if she sees white flowers, then she's gonna chop off their heads. She wants red flowers. The queen is gonna march along the bottom. Whenever one of our cards is a 2 or a 3, she's gonna move forward, and if she gets to this spot, then we all lose.
Oh, I see.
So our job is to color the flowers one at a time. And hopefully not draw any 2s or 3s from our cards. Okay. Everyone ready?
Yeah,
Yeah. Okay, you have the,
Which one was spades?
that's the ones that 2 through 9 of spades. Okay, so I'll take all the other cards, and you're just gonna deal out 4. And yeah, only the 2 through 9, so no ace, no 10, no ace cards. And the 10. Okay.
4 each.
No, just shuffle them and then give Jody 4. And we'll just do one problem at a time. Your job in a math class is to practice the subtraction. So see if you can get the subtraction done faster than I do.
And are you the queen? This game? Are you the queen in this game?
Am I the, no, the queen is automatic.
Okay.
I'm just the secretary.
Okay.
Okay, so what are your 4 numbers?
6, 3, 9, and 7.
6, 3, let me make these a little bigger. 9 and 7. Okay, so again, the biggest one, in your case, is 9. The next biggest is 7. The next biggest is 6, and the smallest is 3. So we're trying to do 93 minus 67. Did we see a 2 or a 3? We did. So already the queen is marching a step,
Wait, when did we see it? For 3?
because there's a 3 here that she picked.
Okay.
So 93 minus 67, how would we do that? So try that on some pencil paper in front of you. See if you can do it faster. I'm gonna wait a moment and then delay.
How does the queen see the? Or what was, whatever was
It's
there?
whenever somebody draws the 2 or the 3. Right, so she had 4 cards and there was 4 cards still here. If the 3 was still in Chloe's hand instead of being revealed, then the queen would not move.
Okay. Since we drew like ratios off.
Sean just said it, 26.
26. How did you get 26, Sean?
I just did the math in my head. Cause I would have to carry the 9 over where the 3 is. And subtract from the 7 and 13.
Or you could also put have the 9. And just plus 3 and 6, and that would be 9, and then just add.
But
the
then
seven
the
on top.
rule where they make the second I'm on, the 93 will be turn 80. So and when I subtract from the 3, the 13 from the 7 turns into be 6, and then the 8 and subtract by 6, 20.
Okay,
Oh,
so let me write that. All of that sounds good. So the 9, we get rid of the 9 and make it an 8. One of the $10 bills goes away. From that $10 bill, we get 10 ones, so now we're up to 13 ones. 13 minus 7 is 6, and 8 minus 6 is 2. So 26 is closest to 30, so we'll move someone to 30. Do you want to paint on the right or the left, Jody?
The right.
The right, okay, so she paints the rows on the right, and you can pick your own rows if you. Okay, so we'll move these back into Chloe's hands and she'll shuffle, and now it'll be Sean's turn to pick out 4 cards. Don't pick a 2 or 3.
Yeah,
No.
I think let's take a big pick at a 2 or 3.
I'll say, I can't, I don't wanna cheat. It's 4. That's a bit more.
Yeah.
Okay, which 4 numbers did you get?
7, 8, 6, and 3.
7, 8, 6, and 3. So the queen does move again with the 3. 2 or 3
I
might
think
be
you
a
don't
little
get
too
too
fast.
fast, I think.
Maybe we have to make it only 2s or only 3s or something. Anyway, the highest number is 8, second highest is 7, then 6. And then 3, so very similar to last time. Now it's 83 instead of 93 minus 67. How is that gonna change our? Practice on your own if you need it.
I'll say 16. Because you're a little less than, you don't have it at 90, so you have the 80, so that becomes 7. And then the 3 becomes a 13. And now it ends up with 6 and then 16.
Okay, so your pawn is closest to 20. Where do you wanna move a flower?
On
Right
the
or left hand?
line.
Okay. Should we give Gavin a turn or let someone in Zoom have a turn?
You wanna try it, Gavin?
Doesn't matter.
Okay, I'm not sure how to give cards to the people in Zoom, so deal them out or hold them out, like Gavin, pick 4.
But remember, don't get a 2 or 3, Gavin, Sean and I made that mistake.
Not like he can control it. What did you draw?
No, 2, 8,
2,
9,
8,
4.
9, and 4. Okay, that is a 2, so the queen moves.
Closer and closer.
So the biggest is 9, then 8, then 4, then 2. So now our subtraction problem looks quite a bit different. It's 92 minus 48. So again, practice it. Your paper and pencil, if it's good to practice.
That 40 looks like an 8.
48. So
No, David said 40. No.
That should be 48.
it's actually 48.
Okay, I was just,
But we can't do 2 minus 8, so.
yeah.
Under pencil.
Have a pencil,
Go ahead.
a pen.
Ah, thanks.
I'm sorry.
I'll do
Sorry.
it. I'll show you.
Somebody's,
It's okay, I can mute for the video.
is squeaky.
It's stopped for now. Okay, what do I change the 9 into?
An 8.
8. And then the 2 can become a 12, 12 minus 8 is 4. 8 minus 4 is 4, we get 44, so Gavin gets to move 40, which you want to color.
Let the zoomers. decide.
Okay, left or right, people in Zoom? I see a thumb for right, okay. Do you wanna keep going, or have we had enough of the game?
I wanna keep going, this is fun.
You wanna keep going, okay, I will put the cards back. Oops, no. I will put the cards back. There, now I can grab just the cards. Okay. Somebody shuffle the cards and Chloe can pick 4. Then it's her fault if we get a 2 or a 3.
Sean's good at shuffling, Chloe, I'm not.
You better count the cards, Chloe.
I'm trying to shuffle a little bit.
Yeah, I thought a lot of.
Look at his hands, how he's shuffling.
Trying to make sure everything's shuffled properly. Go ahead. Pick your cards.
7, 4, 8, 3.
7, 4, 8, and 3. Maybe we should make the goal of the game just to paint one rose bush and not all of them. There's no way we're gonna make it now. The queen is moving it.
Oh no, the queen's moving up
Okay,
again.
8 was the biggest, then 7. Four, 3, so we have 83 minus 47.
Come on.
83 minus 47.
Yeah, so tell me what to do with the 8, the 3, and
I would,
Adentro.
I would carry. Oh, and
good catch.
so I would say.
83 minus 47 is 36.
Okay,
Cheating.
Cheating here.
without cheating, how do you do it?
No, I would say I would make the 8 to 7,
Okay, so we take a $10 bill away, we have 7 10s left instead of 8.
and then you pick the 1 over by the 3.
Okay, so that's a 13.
And then you subtract 13 from 7, 6, and you got that.
So we're back to 36, which is closest to 40. And we can do another rose by 40, okay. Here's a question, on purpose, I'm writing this in different ways. Sometimes I put the 10s and the 1s floating up above in the 1s column. Sometimes I just put like a 1 there. And using the 2 was already in the 1s. So you can write it either way. Some people like one way, some people like the other. Sometimes it depends on your handwriting. Okay, it is 7 o'clock, so I think we should do a little break. Move on from the game, I think.
Oh, darn it, I found it too much fun.
Thanks.
There's a weird thing here, this one is for people that really love math puzzles in Alice in Wonderland, but is not really part of Math B. And here's something to think about as we're on our break. There's a lot of math hidden in Alice in Wonderland, and one example is the Mad Hatter's watch. At the tea party, Alice comments that the watch is strange because it tells the day of the month, but not the hour. And it's 2 days wrong. The author is making fun of some watches which were now very new and fancy with their technology that would tell the month as well, or the day as well as the hour, right? Nowadays, if you had a pocket watch and there were little dials on the side that told you what day number it was, that wouldn't seem so fancy. But back then, that was really new and fancy. But the Mad Hatter's watch doesn't tell you the hour and the day, it only tells you the day. So that's the story in other places subtly reveals that it happens May 4th. That was the birthday of Alice Little, the girl that Lewis Carroll was telling the story to. So the story was a birthday present to a girl named Alice Little. And the story was written in 1862. But if you look back at the astronomical records on that day, there were 48 hours difference between the calendar months and the lunar months, like in the Chinese calendar with the lunar months. So the Mad Hatter's watch actually follows the lunar calendar because it's 2 days wrong. So I don't know who figured that out. I found it on the internet, but little Easter egg in Alice in Wonderland. So maybe while you're taking your 5-minute break, think about some math that you know that's hidden in a story. If you know of any more things. So I'm gonna pause the recording. Okay, welcome back after break. Our next to-doodle is about the envelope taxman challenge, and we're starting multiplication. So let's real quickly take a break from the to-doodles. And if I go to multiplication and division, as usual, we have the 2 books and the whiteboard. I've now been good and put which to-doodles go with which math topic. So in case it's not obvious, you can see that. I've gone through and found all of the good videos again and updated the links so the links work. And sometimes it's playlists and sometimes it's individual videos. Our class recording for today, I'm not sure. I'm not sure if we should put it here or in the addition subtraction one or both. I can put the link in both places. But we'll talk about multiplication. There's worksheets for multiplication and division. And not that you probably need this, but if you're close to taking your GED, then this is a speed quiz. Where it's just a blank piece of paper. And you use either 10-sided dice if you own them, or a website. Like this one that rolls dice. You can say, I want 10-sided dice and 4 of them. And is it ever gonna stop? Yeah, stop, there we go. 7, 4, 1, and 3. So you would write out 7, 4, 1, and 3. So you make up 2 5-digit numbers and then you multiply them and you see if you can finish in 3 minutes.
I'm gonna go wash my hands and go to the bathroom, I'll be back.
So if you need to
If I don't
practice
fall in.
your multiplication tables to get fast, this is just a page like that. Again, the GED will never ask you to do a 5-digit times 5-digit multiplication problem. You can use the calculator. But there are times in the GED where it helps to have your times tables faster. So if you want some practice, we have some games coming up that are more fun, but there we go, have a place to practice. And then there's separate homeworks for multiplication and division.
Okay.
As always, don't jump to this homework, right? The first thing you should do is say in the nice textbook, I am in sections 1.5 and 1.6. So let's look at that. Let's go to 1.5. And then you start reading that, and maybe you look at some videos if you want for the example problem, or you say, do something just like this.
That was the algebra.
Ta-da! and so on. So go through the textbook first, doing as many practice problems as helps you. And then when you're done with that, then you can go back to the My Open Math and, like the icing on the cake, prove that you got it. But this isn't gonna teach you anything. This is just to show you got it. So use the textbook to actually learn it as much as you need to. Okay, but we're gonna start just by talking about factors in an interesting way. Our warm up now is a little different. We have these circles. And we're not multiplying yet. This is an addition warm up because we haven't talked about multiplying yet. But we're gonna choose any number, so maybe 1. And then we're choosing another number, but it has to be a different row, so we can't put it in the top row anymore. And it has to be in a different column, so we can't put it underneath the 1. Then we're gonna pick another number, maybe we'll pick 12. And again, we can't use these rows, they've been used up. We can't use these columns. And then the last one, we again need its own row and column. And if I add these all up, 1 plus 6 plus 12 plus 15. What do I get? So 1 plus 6 plus 12 plus 15, I'm getting 34. So somebody else, I'll pull you towards me in just a moment. Do the same thing. Take the red circles and pick any number on the board from 1 to 16 to start with. And then we'll go from there. Oh, don't move the whole thing, just move the numbers. Or move the circle. So Betty is putting that circle on.
I did follow.
Okay, so different row and column. 6, okay. Okay, if I add up those are different numbers. 4 is different, 6 is the same, 11 is different, and 13. If I add those up, what do I get? 4, 6, 11, 13.
I took the belt off because it's too tight on the stomach.
I get 34
I put it
again.
in there, so I would forget it.
Okay, I'm gonna move the numbers again. Someone else, not Betty, grab the circles and put them on your choice of 4 numbers.
What are we doing? I was in my office, I
We're
forgot.
picking 4 numbers that are different rows and columns from each other.
Confusing.
It's not confused, just pay attention.
It's a little confusing.
It is kind of sort of confusing, but I understand it because it's.
No, I'm just saying it was confusing because you guys are going too fast and I was going to the bathroom. Okay.
Okay, so see how all of those are in different rows. And also different columns. Now 2 of them are in the same row. In the 3rd row, there's 2 numbers, so the 10 or the 12 needs to go down. Okay. So now we're going to add up 3 and 5 and 10 and 16. And we're again getting 34. So this is always gonna add up to 34, it turns out. Can anyone see why?
As I see it all the time, is that they're not.
Because of the 3s, the 5, the 1, the 0s, and the 6, that's how it's ended up to 34.
Right, but when we picked 4 other numbers, like if we put this one here and that one there, it's also 34, right?
Yeah.
Or if we put that one there and this one here, it's also 34. As long, whenever you have different rows and columns for all the numbers,
It
it's always
just, it's
34.
all adds up the exact same way. Almost exactly.
It does.
It's kind of neat to think about it. Yeah.
Okay, well, ponder it more. I'll give away the answer on Thursday. Because I'm gonna forget.
Because I think I got it.
You think you got it? Tell me, Bertha.
I
Bet-
think I got it. Because there are four rows and they're then 4 by 4. No, it's because there's 60 numbers and 4 rows. So makes sense.
Four.
There are 4 rows with 4 numbers.
Right.
And
You're
that
on the
make
right
you,
track.
yeah, and that make you the same number. It's if you go straight or go down, it's 4 numbers.
Right. You're close, but not quite there, because there are certainly times you can add up 4 numbers
But
and
it's,
it's not 34.
You could just announce,
So what makes it always 34? So I'll tell you again on Thursday, pondering it.
because you divided.
We forget between now and Thursday.
Now, somebody has to remind me, because I might not. Moving on to factors, so we're really starting multiplying. So there's this nice book, Building Thinking Classrooms in Mathematics. And it talks about how to teach math well. It's a great book if you want to get it from the library, because then you can say, oh, yes, it's my math teacher's fault all those years, they weren't doing it right. So it's kind of rewarding to read in that way. But this is a task we're getting from that book. And we need to know what factors are. So what are factors? Factors are the numbers you multiply to get another number. So like 3 and 5 are factors of 15, because 3 times 5 is 15.
yeah.
But 1 and 15 are also factors of 15. Because 1 times 15 is also 15.
Yeah.
So a lot of people like shapes like this. And if you want, I'll go into my office and get little blocks, and you can make rectangles with blocks. And the factors are all the ways to make rectangles with that many blocks.
Yeah, that looks like fun, I think I wanna do that.
So the factors of 12, 1 works and 12 works, because you could just make a long row of blocks, and that's 1 times 12. 2 works, because 2 and 6 makes a rectangle that's 12, right? 3 works, because 3 and 4 are the edges of a rectangle with 12. 5 doesn't work, there's no rectangle that has 12 things where one of the edges is 5. Same like 8 doesn't work, right? So note that 1 and the number itself are always factors. That's like the train or the caterpillar, right? That's this one up at the top, that's just a straight road.
That's a caterpillar, I thought that was a worm.
Could be either.
Could be, bro.
So that's how to think about factors. I'll get my blocks in just a moment. But first I want to show people this. So while I'm fetching blocks, I'll pull everyone towards me. Then your job is to take from the top square, find 2 things that are factors of 5. So maybe I think 7 and 8 are, but no, those don't multiply to 5, so that's 1. And then from the middle square, find 3 factors of 9, and from the bottom square, find 4 factors of 6. So you work on that, and I'll be right back after I fetch things from my office.
Okay.
Nice, nice. There you go. You were doing multiplication, I believe. If you, yeah. You're not doing it right there, see. Okay. But all 3 factors of 9, so you may have to do it like. How do you do this?
Okay. Okay, so this pink one here says find all four factors of six. So here's six, so range those in some way. And then here's another six. Show me a different rectangle. Six. Show me two different six. Okay, so the top one is perfect. One times five is five, there's no other ways to multiply to get five. For nine, you could have one times nine, that works. And you could also have three times three. So those all are factors of nine. How about six? How do we multiply and get six?
I did one was two and three. So that. I'm not. Sadly, first Tommy.
Here's Tommy.
Hello.
Hello, buddy.
Okay, so Jody made one rectangle behind me that looks like this.
Still don't have the skateboard.
I got someone.
Oh, that's not good.
Sorry, my transportation.
Limited, huh?
But I'm gonna get this fixed soon.
So that's 2 and 3. So here's the 2 and the 3 for those. And what's your other rectangle that makes this? Sorry, Kenny.
Go ahead. Like that's. I can see that.
You're making the same rectangle,
I'm sorry.
a very different shape right there.
Okay.
Just get it there. Okay, so the other way, now she's doing that.
It's a long way, there we
It's
go.
like the worm caterpillar train way. So that's
Sounds good.
the 1 and the 6.
There now.
Okay, so the 6 works and the 1 works, 4 is not a factor of 6, there's nothing times 4, we get to 6. So
And
no
the-
rectangle has 4 as the edge, right?
Yeah.
Everyone okay with that?
Mhm.
Okay, so here is the challenge. Again, I will bring everyone to me.
Yeah.
So you have 12 envelopes.
Thank you.
And notice that. I'll lock this, by the way, lock that, and lock that. Yeah. So notice the envelopes you can move around. They have money in them, $1 to $12. And you get to claim any envelope you want. So say we want 10, so we'll put it in our basket. But there's taxes in this strange
Oh, darn it.
world. The tax man is gonna get all the envelopes that are factors of ours. So if we pick 10, the tax man will get 2 and 5, because 2 times 5 is 10.
What if we fire
And
the
the tax man also gets 1, because 1 times 10 is 10, right?
Mhm.
So we got more money than the tax man, we got 10, the tax man only got 8. But we didn't get a whole lot of money. Right, so I'm gonna put those back. And I'm gonna make some copies of the envelopes, so if we want to start over, it's easier to do that.
These days.
Okay, so your job as a group is to figure out how to get the most money. What envelope to pick first and second and third, and the order matters. Cause if I grab 12 first, the tax man's gonna get 6, right? But if I had done 6 on an earlier turn, the 6 is in my basket and the tax man won't get it. Does that make sense?
Yeah, but you wanna try to get yours back.
You wanna take as many turns as you need and get as much money as you can,
And talk amongst yourselves.
right? The only last rule is that up here, you can only pick an envelope with at least one unclaimed factor. So if you pick an envelope that's like, say I picked 2 and the tax man picks 1. Cause 2 times 1 is 2, so 1 is a factor.
And
I
big
can't-
one and the tax man loses.
Then I can't pick 11, cause there's nothing for the tax man to pick, so that would count as tax evasion.
Okay,
So some envelopes might be stuck in the middle and we're not allowed to grab them.
Oh, you gotta talk amongst ourselves.
So how can you do this? And if you want to play by yourself, just grab one of these, make your own copy of it. And you can kind of fiddle off in the margins and see if you can develop a good strategy before you tell all of us. Everyone understand the puzzle?
Yeah,
Take an envelope and then see, taking turns between you and the tax man, how much money you can get. Do you want to do one round all together to see how it works? That might be smart.
Yes.
Let's do. Okay, so if somebody shout out, what number should we take first in our first group attempt?
what number should we take first and the tens,
Is Jody suggesting 6 with her? Just grab the 6 if you want, Jody, you can move it.
Grab the 6, you suggested.
Okay,
4.
so if we get 6, the tax man gets 3 and 2, because 3 times 2 is 6. And the tax man also gets 1, because
Yeah,
1
that's
times
half.
6 is 6.
that's like it's a tie. It's like a tie, I don't know.
Okay, so what's our next envelope? I'm also wondering, let me pause a moment. So your homework again in both addition and subtraction section and in the multiplication and division section is to do whatever you can. Go to the textbook. Right, click on the textbook, do some practice problems, and when you feel ready, then go to the My Open Math and do the doodle. So as much as you can get done, it will be.
I'll take 5.
Okay, so Sean suggests 5, so 5, does the tax man get anything? No, then we can't get 5, because that's tax evasion.
Okay, I'll try 4.
There's still no factors of 4 available for taxes.
Stan. How about an 8?
8, so we can get 8 and the tax man gets 4, because 4 times 2 is 8. Then what will we do?
Okay. Well. Let's sit it out, who's next?
I've already went, so it's up to Tommy and Gavin.
There's only one number we can take, we can't take 5, because there's no factors of 5, there's nothing smaller than 5.
What about 9?
9 would work if there was a 3 or
And
a
he's got
1.
3 of it.
Yeah, but he already has it, so we can't do 9.
That's
So
it.
11 and 12 also don't have any factors out on the board still, only 10 we can.
What about tens?
So we can do 10, the tax man gets 5, and these 4 numbers are stuck in the middle.
Oh, okay, now that's kind of.
So our total is 10 and 8, which is 18 and 6 more, so our current record for the game is 24.
Oh, nice.
And the tax man lost?
No, it doesn't matter how much the tax man gets, what matters is how much money can we get in the game, does that make sense?
Always wins.
So, can we get more than the tax man? That's a different thing. In this case,
No,
we
the
did.
tax man does not always
In
win,
that game,
Gavin,
the
we
tax-
can fire him.
In this game, the last game, the tax man only got 15 and we got 24, so we did do better.
Doesn't matter, he's still got your money.
Okay, so try it yourself, talk to each other, see if we can beat that record of 24.
Okay, I just hit my leg. Who should I do this with?
I'm gonna go sit in here. Where's Katie? No, where's me? No. Okay.
Come on, I'm
I
doing
think to do it. Are people dragging things and trying? Just don't mix up one set of envelopes with another set, because you should have 12 envelopes that are just for you to use.
So which number do we wanna use, honey? We have to talk amongst ourselves. And you're the closest person to
Geez. You want to?
No, Gavin and Paul, see if I'm finding
between 12 or
answer to break the 24 record.
What about, what about would seven, 2 or 9 work?
No.
Well, if you were gonna do 12, taxman only get 1, 2, 6, and 1.
And 3 and 4,
And 3 and 4,
that's a lot.
That's a lot.
And she picked 7, if we get a 7 to start with, what would the tax man get?
I'm just trying to.
Only one, only the one, so that might be a good start, but maybe there's an even better start.
Yeah, does that work for you, honey? Should we do 7?
If you can do it.
Go ahead, try it and see. Play up the game and see how much, if you can beat 24 or not.
Okay, I'm gonna give 1 to the taxman here. Okay, what else? What about 9? There's 9 and then the taxman gets 3 and 2, right? For 3.
Just 3, not 6, 6 is not a factor of.
Okay, good. Where's the 7?
Oh, I blocked it by accident.
Okay, what else?
Maybe you can reset.
8, that'd be good one. What about 8? 8 and then taxman gets 2 and 4.
Would 10 or 12 work?
People in LCC manage.
Those can both work, if you get 10, the taxman gets 5. If you
Were
get
they,
12, the
were there 12 then?
Yeah.
Wait a minute, I gotta think if I really want 12 or 10. Yeah, 12, I'll stick with 12.
Okay, and then 12 and then the taxman gets 6. Okay, what else?
I would say, I'd say 10.
Should we get 10 and then the taxman get 5 and.
And I would say 11.
11, you can't.
11 doesn't go.
This just sits in the middle. 'cause
Oh, yeah,
there's
the
no
11
taxes.
sits in the
You
middle.
can't claim something unless there's taxes.
So
So
we'll-
now you have 10, 12, 8, 9, and 7. So what is 10, 12, 8, 9, and 7? You got $46, so a whole lot more than before.
Mm-hmm.
And the taxman got like at least
Taxman got
21.
21.
Okay, new record. Doesn't matter what the tax man.
Yeah, taxman doesn't count, it doesn't matter what he gets.
Can we break our record at 46? Is there any way to play the game even better?
I don't see any point going higher.
I'm with my husband, I don't see any point of going higher either.
I see, well, you can, the 11 was in the middle, maybe we can use the 11 earlier and get that 11, and that will make our record even higher.
That makes sense. If you swap out the 7, make this an 11, and then everything would have been fixed. It would have been higher. Cause it would have been. So let's try this. Okay, we start with 11.
Okay, start with,
Taxman gets 1. And then I would start with 12, 6, and 2.
And
3
3,
and 3 and 4. And 4. And then I get 10 as well, then that's 5 there. And then 9.
then I can't have the 9, 'cause
Oh, yeah, let's see, hold on, alright, that's good.
so we can't have the 9, so we could only either have the 7 or the 8, or the 8.
no, none of
I mean,
it,
I'd say the 9.
we can't grab any of these, because they have no small factors for the tax man.
Mhm.
Okay,
So now we only got 23, so somehow You didn't make as optimal
33.
choices, 33, so you didn't, your choices were not as optimal as before.
Yeah, so that was out. So that is.
Anyone else have a solution to this? Can we get close to or beat 46?
Cause we got greedy, so what we did is got greedy.
Starting with 11 and the tax man only gets 1, that seemed a good way to start.
Yeah.
But picking 12 gave the tax man lots of options. And it meant that you had trouble picking anything else, because all those small numbers got used up, right? The 2 and the 3 and the 4 and the 6 all got taken off the board.
So you should use the 10 instead and the 9.
So if you do the 10 instead, the tax man gets 2 and 5. 5 times 2 is 10.
And what about the 9?
You can do 9 and the tax man gets 3.
What about the 12?
No, that we don't use
Oh,
that.
I mean, what about the 8?
You can do 8 and the tax man gets 4, because 4 times 2 is 8.
And
And
that's
then,
it.
and then the 6, 7, and 12 don't get used.
You can use one of them. Which one can you get?
And what about the 12?
If I get 12, the tax man gets 6, because 6 times.
I mean, not 12, what about 7?
That's
Too late.
No, you would need the 1 to get the 7. But now we have 12, 8, 9, 10, and 11.
See what the number would look like.
So 12, 8, 9, 10, and 11 gives you 50.
That's higher.
That's higher, that's our new record. That might be the highest we can get, I don't know. So play around with it if you want and see if before next class you either agree that 50 is the best we can do, or you find some way to get more than 50. Any questions about this game?
No, this is too much fun of a game for me.
It's making you learn, it's making you learn so much.
Yeah, it's a good book about how to teach math. Anyway. So thinking about this, we ignored advice from that book. If you read the book, it tells you things to do. One, it says that the best way to learn math is giving all of the instructions only out loud. Maybe demonstrating them, but don't ever give people written instructions, but we had written instructions in front of us. Then also we all work together as a class, or were quiet while other people were working. Whereas the best way to learn math is to randomly assign groups of 3 students. So if you ever had a teacher that like put all your names on popsicle sticks and put them in a cup, and then, right, that's the right way to assign groups. And also we're sitting in Zoom and using a virtual whiteboard. And the best way to learn is to stand around at the wall, and every group of 3 has either their own big piece of butcher paper or their own board to write on.
Is this like playing musical chairs?
Yep, you'll have different groups for different problems. And instead of each group having its own whiteboard, then we're sharing one. So if we could change just one of those, which would you want to change? Would you want me to give instructions only out loud? Or would you want me to break us up into groups of 3? Or would you want me to let all of you write on your own boards? Or would you want to have the groups all write their own things?
I would say, and I don't know about anyone else, but in my opinion, I would say bring in the groups of 3.
We can try breakout rooms and things and see how that works.
Yeah.
I mean, I'm not learning anything because everyone's just free for all and all that jazz, and so I would like to learn a little bit.
Okay, well, let's do more with factors before we're done. We have a few more minutes and I'll make it less free for all. Okay, I'm gonna skip the warm-up problem. This is a great one to do. It helps you think about factors, but we're not gonna have time for it now. Maybe we'll do it Thursday. A little bit of review in case it had been a few days since, between 2 doodles, where here's what factors are. And this game is the most fun I know for practicing multiplication tables. We showed you in Zoom, not Zoom, in Moodle a moment ago, that boring way to write out pages, but here's the fun way. So somebody is X's and somebody is O's, it's like tic-tac-toe. And we're gonna make copies of this, Control C and Control V. And somebody is going to pick a number, like the taxman problem, and the other person gets the factors. And once something is claimed, then it's all used up and you can't have it anymore. So, I think if it's okay, anyone in Zoom sad if I just have Gavin and Tommy play?
I don't mind.
You don't mind? Okay, so let's make some copies.
I don't know how to get to the site, so I'm not really on the site.
It's at the, oops, what did I do? Somebody, like,
You could just.
it's at the very top of the,
Somebody keeps moving.
I said he could just move
Very
the
top
X's
of
and
the-
O's for us. That's what I would thought too. Can you do that actually?
yeah, I'd rather have someone that can move their own X's and O's, so, just so it goes faster. Okay, so here's a bunch of X's and a bunch of O's, we can make more if we need them. Okay, who wants to play against Gavin? Who in Zoom is wanting to try this?
I guess nobody in Zoom wants to try it, so I will play against it.
No, you just talked a lot, let's let somebody have a turn, somebody will speak up. Or we could have everyone in Zoom against Gavin, they can team up against us.
I'm almost there.
I'm just looking.
I need to see how it's done before I
Yeah.
try.
Okay, well, I'll start, Gavin, pick any number and move an X onto it.
Restart connection. Oh, placement's definitely should, placement's yes.
You're not supposed to be on that.
Oh, I'm just looking. Save that.
What do you want me to do?
So grab an X and put it on any number you want on the board, but just be aware that Nicole is going to get your factors, like she is the taxman. So if you put it on 30, 30 has a ton of factors. So that is the biggest number and you'll get 30 points, but she's also gonna get a ton of points, right? Okay, so Gavin picked one, not ambitious, but on the other hand, Nicole doesn't get anything for free. Right, there's no factors of one except for one, and one is now claimed. So that was his turn to start and Nicole's turn to reply, make sense? Now we switch roles, so Nicole gets to pick any number she wants and put his O on it, because she's the O's.
So anywhere on the board?
Anywhere on the board that's not claimed. So she picked 15, so help me call out, what numbers does Gavin get, because she picked 15? 1 times 15 works, but those are both claimed. What else are factors of 15?
5,
5,
3,
And 3.
so that was a good move, she got 15 points, he got 5 and 3 is 8, so she came out ahead by that, make sense? That was her turn to go first and his turn to reply, so now you switch again, so he gets to go first and pick any number he wants, that's not covered. 2, okay, so he's still aiming low, but she's not getting anything. Now it's Nicole's turn to pick any number she wants, they'll get the factors. Is this making sense now?
Oops.
25, so what are factors of 25? 1 times 25, but those are covered, what else?
25.
Yeah, I heard it whispered, 5 times 5, but 5 is covered also, so she just got 25 points without anything coming to Gavin's point. See how that works?
Kind of.
That was her picking and him trying to get factors, although they were all covered. So now it's back to his turn to lead, so he picks any number he wants. Okay, and factors of 4 would be 1, 4, and 2. Those are all covered, so Nicole doesn't get any. Is this making sense now?
Yeah.
Yeah, okay. I know. Should we start all over and do roomies versus zoomies? Is that better?
Yes.
Yes? Is that okay with
Because it
you?
looks like I lost.
I don't give a damn.
Okay, let's all work on it together. So the people in the room with me, we're X's. What number do you want? Knowing they will get all the factors.
I want 0.
You want something pretty big, but without too many factors.
3 zeros. Without any numerals.
Ideas?
Yeah, 28.
28, okay, is that okay with the rest of the people in the room?
Mhm.
28. So what are factors of 28? 1 times 28, so the zoomies get the 1. What else makes 28? When you multiply.
4.
4 times 7 is 28.
I'm saving them.
3.
3, no, there isn't a 3 times anything.
What about 14?
14 times
two.
what, and 2, so those are all, so we got a bunch of points with 28, they got a fair number of points also.
Yeah.
So I think we came out ahead, but not by a whole lot.
Mhm.
125, yeah. Okay, so now it's the Zoomies turn, to pick a number, and we will reply. So they pick any number they want.
So are
18.
the zoomies the zeros,
Yep,
the
good.
O's?
Yeah, so move an O on anything you want. Betty suggested 18. So do that or talk about it or suggest 18. Okay, so what do we get? What are the factors of 18 that aren't covered yet? It's okay if you take out your calculator, you can do 18 divided by 2, does that turn into anything? 18 divided by 3, does that turn?
Susana. Estoy en mi clase. Ya. Oh, they almost finished. They almost finished.
We're X's, right?
Yep, we're X's.
Okay, and we're trying to choose our next number, correct?
No, they just did 18, so
Right.
what are the factors of 18 that we get in reply?
Okay.
We get to respond to their things. So I'll share one. 9 times 2 is 18. The 2 is taken, but we can have the 9. And what's that multiplies to get to 18? 3 and 6. Okay. And then that's finishing our reply to their thing. So then it would be our turn to start, and then they'll be the next. Right? So what number do we want to pick? And then we'll do this last round, and then we'll stop because it's out of. So actually, why don't we just stop now? We each had one turn. So we can do this more if we want on Thursday. It's a good way to practice thinking about factors, or we can move on to the other things. Okay, any other questions about homework or textbooks or whatever?